I really wish I had read your book about a couple of months back because I'm super new to this whole LLM thing, right?
A lot of people are.
We're doing something at work which requires this, and that was kind of like my motivation to get into this. Um, I'm primarily a Java backend developer for a long portion of my career, right? And that's what I've been doing. I did a little bit of front end as well. So a lot of like imperative code, like thinking, this is the input and this is the output. Like you gotta, the preciseness and the predictability of coding, and this
Determinism.
Determinism, exactly. And this whole LLM thing has kind of changed my
The opposite.
it kind of
In a lot of
forces you.
ways.
Yeah. It kind of forces you to think differently, doesn't it?
Yeah. It's actually it's funny you say that. It's one of the main drivers of why. So I've been working in NLP for over a decade. Even before OpenAI existed, what we currently call LLMs existed. Language models have existed for a long time, and the idea of completing the sentence or ingesting text to make some task happen is not new.
Mm-hmm.
And it's always been the case that any kind of AI, machine learning, for the most part, is going to be non-deterministic to some degree. What's different is that what we would today consider classical machine learning models like decision trees, even random forests to a degree, or linear regressions, a lot of those do come with a sliver of determinism, right? The training process is actually the non-deterministic part. Training the model can be non-deterministic, but for the most part, even the simpler models, especially the simpler models, like a linear regression, you put in the same input 10 times, you're getting the same output back because you've learned the coefficients. You're just at this point, you're just multiplying numbers and adding them together. Like that's going to be the same thing every single time. Today, modern generative AI and LLMs in general, non-generative LLMs included, do have this spectrum of non-determinism that you can control with inference parameters like temperature and top P and top K, but those parameters exist because of this non-determinism, because people are used to this idea of, well, input in, output out. And if I put in the same input in twice, I should hope I get the same output twice. But that's just not the case with LLMs.
Do you have a background in like coding the imperative deterministic way for a long period? Did you have that before you started this field, or did you kind of get your start from this field?
That's a good question. I haven't talked about this in a while, but my background is mostly in theoretical mathematics. So my degrees are all in math. My bachelor's and my master's, they're all in pure math from Johns Hopkins. I got a minor in computer science. I took my experience with Java began and ended with intro Java in college, and teaching intro Java as a lecturer after I graduated. But I have actually personally, frankly, I have never actually used Java in a production setting. So sorry to everyone out there who was expecting it. But to your point, I learned a lot of the coding, the software engineering skills on the job, so to speak, when I was starting my first startup in 2014. We eventually got into Y Combinator with a generative AI startup in 2015. A lot of those skills came from my friends, frankly. I had them kind of give me crash courses in software engineering. I tried and failed to put up servers many, many times until it worked. And then I learned from those mistakes. But no, my classically trained background is actually in mathematics.
That's as deterministic as it gets, right? I mean, it's in mathematics,
It can, yeah. I mean, here's the thing. It can be, right? Most when you think of math, calculus and statistics, a lot of that is extremely deterministic, right? There's a formula, you plug in the inputs to the formula, you get an output. As you progress in the field of mathematics, you start to get these hints of non-determinism. These ideas that there are, it starts with the kind of basic concept of there are many ways to prove something. So in theory, if the output you're looking for is a proof, then there are many proofs, and you can't really, they're all equally viable. And as long as you can prove it, you're good to go. And that evolves into this idea of variational calculus, these ideas that, well, not everything is as deterministic as you were led to believe in your early stages of mathematics. And if you've that idea, variational autoencoders with machine learning and AI these days, these concepts are often very much borrowed from theoretical mathematics, right? These concepts of, for example, one of the main ways that we fine-tune gigantic LLMs like GPT-4 is through procedures called PEFT, parameter efficient fine-tuning techniques. And one of those specific ones is called LoRA, low rank adaptation. To the uninitiated, it's magic. It's how you're basically taking an 8 billion parameter model and saying, I'm only going to train these additional, call it 50 million parameters, and it's like the whole model has been fine-tuned. And that's insane. And then for the person who took 2 years of linear algebra, looks at it and goes, oh, it's matrix decomposition. Okay, I understand that. I know exactly what that means. And that idea of combining linear transformations through matrices is just 101 linear algebra. So a lot of these concepts go back and forth, and determinism is actually I would argue, one of those concepts that is kind of borrowed from the mathematics, is that, well, what the type of math that we're doing here is not always deterministic.
In a way, if you think about it, I feel like there is a certain element of predictability and determinism that kind of shapes everything. I mean, at the end of the day, you're looking at code which runs on a machine. And coming back to the experience that a typical Java developer would have with AI is, even though what's happening, like the machine that's running the code is essentially deterministic, going through the same electronic pathways, the impression, the behavior that you as a consumer of a language model gets is that indeterminism, especially if you're coding with it and you have like the output of a language model going to another language model, and the more layers you have, the more kind of like it branches out. It's almost like pseudo random in a way. Do you agree?
It is, and funny enough, there's a way to turn that off. In a sense, you can turn off the non-determinism of an LLM. I mean, frankly, all of the determinism at inference time, at least, again, training itself is a whole other area of non-determinism, right? Anyone who's done any deep learning or gradient descent knows that you're not going to get the same training procedure every single time unless you fix every single seed, from A to Z. But at inference time, you can effectively turn off non-determinism by saying the goal of a language model, to be very clear, at the end of the day, is to take in a bunch of text or images, to combine them together, doesn't really matter, but it is to produce tokens, words, one after another in a stream. And to produce a single token, it has to say, okay, well, I'm going to take in this input, I'm going to process it through my attention mechanisms, whatever it is on the inside, if it's a transformer or, a mamba or striped hyena, it doesn't really matter at the end. But once I've processed it all, it kind of comes down to a classification question, which is, okay, I have a vocabulary of, call it 100,000 tokens, words, effectively. Which one should I say next? And the non-determinism is mostly coming from that step in saying, well, I have 100,000 tokens. This token has a 99% chance of being correct, but these other tokens technically could work too. So it selects which of those tokens to say in a probabilistic way. Okay, I have a 99% chance of picking this token, a 1% chance of picking this token. And sometimes the 1% wins, and you could say that 1% token, and now the model says, well, I've already said it. Now I have to keep going with that chain of with that thought. Yeah. But you can turn that off. You could just say, always pick the top token and say, that's it. That's all you're allowed to do. And if you do that, you've effectively turned off all of the randomness. You've turned off the non-determinism.
Yeah, that's the temperature setting, right? And the top P, those are the settings.
That's actually, that would be called top K. Top K, which I'm pretty sure is not an option on OpenAI, but is an option for any open source LLM, is just which K tokens, let's say you have 100,000 tokens, only allow the selection of the top K. And if top K is 1, that's called greedy sampling. You're just basically greedily picking the most common or the most likely token every single time. Temperature affects that probability distribution, but it technically doesn't take any tokens off the table. It makes, if it was 50% versus 20%, it'll make it sharper. If it's a lower temperature below 1, if it's a temperature above 1, it makes the probability distribution flatter. So it makes it more likely to select something in the long tail.
Interesting. I didn't know that. So my usually the dial that I would reach out for is always temperature, but this is something that I should try. I play around with the local language models a little bit. I'm going to watch out for that setting.
Temperature is the most common inference parameter, and I recommend most people, again, if they want if they want determinism in their model, turn your temperature down. And now I don't actually know what's happening behind the scenes, but you're allowed to set your temperature to 0 on OpenAI, which is mathematically technically impossible because temperature is what happens when you divide the logits by that number. So obviously you can't divide by 0. So I don't exactly know what's happening back there. Maybe that's a shorthand for always pick the top token. And that's why you get the same one. I don't technically know the answer to that. But in a real, quote unquote, real setting, you can't actually set your temperature to be 0. It has to be some epsilon, some arbitrarily small number. But even with open source LLMs, you have way more options for inference than you do with closed source commercial LLMs. Like you have beam search, which is basically saying, instead of looking at the next token, predict a few and look out ahead a few tokens. And if that looks good, go ahead and pick that first token and start that process over again. So there are actually way more inference parameters than people realize, because most people say they look at the playground and say, oh, I see temperature in top P here. These must be the main inference parameters. And they're crucial. Temperature, I would argue, is the most crucial parameter, but there are actually a lot more under the hood that we could have access to if they were to expose it.
That's interesting. Beam search sounds cool. I had no idea about that.
It is. It's so computationally inefficient, though, that I understand entirely why they would not want to expose that.
It's got to make it's got to go down multiple paths before it comes back.
It literally has to go down multiple paths and pick the best path. And that is there are ways around that. Speculative decoding is one of those. Now I'm just name dropping techniques at this point, but there are kind of clever ways of getting around that. So basically what that means is you have two versions of the model, a big one and a small one. It could be distilled, doesn't really matter. Call it Gemini large and Gemini small. If you want Gemini large to do a beam search, you could instead make the small model with the same vocabulary do the beam search. And then basically it's like a P versus NP. You check that against the large model and say, okay, you don't have to actually think through the paths. I'm giving you, the large model, the pathways to consider between. So just all you have to do is pick one, which is the right answer. It's not exactly P versus NP, but it's the idea of solving the task versus trying to corroborate the task from a smaller model doing the heavy lifting.
Then that makes it less expensive, both in terms of
less expensive, but now it requires a smaller model also in memory, ready to pick up the slack when needed. So there's always a give and take.
And it's also a strategy you can follow for commercial models. So for example, you can have GPT 3.5 come up with those paths and GPT 4 pick one. That's pretty cool. Yeah.
As long as they share a similar or the same vocabulary. Technically, that's not required, but it makes it a lot easier.
Okay. All right. I was going to ask you what got you into this field. So you've been a decade, you said. You've been here for a while, and I would imagine this was a time when there was always buzz about AI, but it was dramatically less than what we have now. So I'm just curious about what got you into this field. Both in terms of the topics that you specialize in and also your profession of teaching.
Yeah. So, I mean, my profession right now as an entrepreneur and a teacher are both pretty obvious once you kind of hear what I was doing 10 years ago. So my goal ever since I was a kid was to be a teacher. My mom was a teacher. Her mom was a teacher. I wanted to be a teacher growing up, specifically a math teacher. I was a cool kid. Very much so. So when I got to college, I studied math because that's what I wanted to do. I finished my bachelor's a couple years early, started doing my master's. And by the time I was wrapping up my master's in that 4-year period, I was deciding to where I want to go get my PhD, because the goal was to be a math professor. And along the way, I was in a fraternity in my college, and two of my fraternity brothers came up to me and said, "Hey, you're the brother who does math, right?" And I was like, "I guess so. I don't think anyone else studies theoretical math around here, but yeah, I am." And they said, "Hey, we're doing this startup, and we'd like you to intern for us over the summer." And I was like, "I don't know how to code, uh, quite frankly, and I've never worked for a company." I mean, again, I was in college basically at the time. I've never really worked for a company before. So if you're cool with both of those things, I'm happy to. They were cool. They brought me in. They taught me the ropes. Now they work for Google and Meta. They're super, super smart people at that company. And we ended up getting a patent for the work that I did. This was in temperature control for basically cold chain medicinal supply. We got a patent for the work. We got a lot of press for it. It was just a lot of fun too, just to be in that environment. So now I was torn between teaching and working at a startup, because now in my head, both of these are equally viable options for me. I love doing both of this. I graduated. I lectured for a few years at Johns Hopkins. I built a course on analytics where I taught machine learning to undergraduates. There really wasn't a machine learning course for undergraduates at the time. I taught graduate students intro Java and intro calculus and linear algebra. I was having a great time. And long story short, I met my current co-founder through a mutual mentor. He had just sold a company and said, "I want to get into tech, not AI specifically, but just tech, machine learning, maybe something of that ilk." And I said, I have a little bit of experience with machine learning from the startup that I did with my friends. And we got together. We ended up building what was going to be one of the first, if not the first, kind of generative AI companies to go through Y Combinator at the time in 2015 rather. And from there, I said, well, I guess now I'm an entrepreneur, technically. And to kind of keep up the teaching, I do my lectures with Pearson and O'Reilly, and I write books. So this is kind of my compromise with myself, is saying I want to teach. I love teaching. But day to day, I want to be building. I want to be working on a project. I want to be talking to customers. So I have my students and I have my customers. And my life is just basically balancing between the two.
I see a lot of parallels on what you said. Of course, I haven't done anything as cool as what you've done, but I
disagree, but please.
First of all, my mom is a teacher, and her dad was a teacher, and for me it was like, yeah, when I grew up, it's like I want to be a teacher too. So there's a definite parallel there. And I too sometimes struggle with this idea of, I want to teach, but then I also want to build something, right? So I have like these two things that I do. Like I have a full-time job at LinkedIn, and I also use my YouTube channel to kind of fulfill my need to be able to teach people. So I see a lot of parallel there. Do you feel like these two things that you do kind of feed into each other? Like your teaching makes you a better,
Yes.
Solution builder, and then vice versa.
Yes, it is. I was just thinking about this last night, because I'm working on the second edition of my book right now. Mm-hmm. And most of the new content, most of what I write about either comes from some task I had to solve at work, or maybe a consulting job that I do on the side here and there, or it was a question that someone asked me in a class. The speculative decoding, I had not heard about that until a couple of months ago, maybe a year ago. I can't remember exactly when, but I had never heard of that until someone asked me, "Hey, what's your thoughts on speculative decoding?" randomly in a lecture. And I had to look at them and say, I have no idea what that is. And I Googled it live. Everyone watched me Google it. I read about it very quickly and said, that sounds like a really smart idea, as long as the vocabulary is, like everything I just told you. A lot of this comes from that feedback loop, because they're telling me what they want to know about. My customers are telling me what's impactful to them. So I have one group of people telling me what they want to learn, which may or may not be quote unquote useful in a corporate sense. And then I have customers who are telling me exactly what is going to be useful in a quote unquote corporate sense. So then the job, my job becomes, how are these two things related? Can speculative decoding be actually useful in production? Of course it can be, but that's not always the case. Sometimes I have to make a choice of, well, this question is much more philosophical than it is codable, right? One of my new chapters coming out at the end of this year is about alignment, like first principles of alignment. And that chapter has, suspiciously very little code. It's mostly just me talking about, well, this is what people mean when they say, here are examples of, X's AI versus OpenAI's AI answering the same question, and here's the differences in their values. And you can see that on the front end, and how that arises from the back end can be quite difficult. So it becomes, again, another balance of what is interesting, what do people want to know about, versus, the name of the book is A Quick Start Guide to LLMs, which is, well, what's the quick start part of this?
Right. I actually have something to ask you about alignment. So glad you brought that up. But before we get there, since we're on the topic of the book, can you talk a little bit about what was your motivation to write it? Who is the audience for this book, and what does the book cover?
Yeah, I got it right here. Quick Start Guide to LLMs. It's actually my seventh book, if I'm not excluding editions. It's my seventh kind of unique manuscript, I should say.
Okay.
So teaching was one of those ways that I wanted to kind of keep my foot in the game, so to speak, right? I wanted to write about AI and machine learning. I have 2 books on feature engineering, which is actually one of my bigger passions in the realm of AI. So my motivation was the same motivation for all my books, which is I have something to say. I feel like my teaching style is unique enough that I can convey these concepts in a way that some people are going to resonate with. To your second question, which is, who are those some people? It's actually very funny. I have read many reviews of my book because I want to be aware of what people think about it. And I often get that the consolidated review is, this is not for people who want to advance the field of AI, which is true. It was not meant for that. It is much more for people who are trying very quickly to understand the broadness of the field, and more specifically, how to map the broadness of AI to the specifics of your task. So one of the biggest critiques of my book is actually that it's the layout is quite confusing, because every chapter feels like it's kind of bouncing between ideas. Chapter 1 is an introduction. This is autoregressive versus auto-encoding models. This is BERT versus GPT. This is what a parameter is in a model, right? It's very level setting. Chapter 2 dives into, all right, now we're going to build a semantic search system and fine-tune cross-encoders to enhance the abilities of an embedding model. And I'm like, people are like, what? That was a big leap. And from there, it's prompt engineering, building an agent, fine-tuning models on OpenAI. It bounces around a lot of topics. And that was quite intentional, because the goal was to both show you the broadness of the field, and in a lot of ways, frankly, make you feel the broadness of the field. Because when someone says generative AI to me in life, I have to look at them and say, I assume you mean commercial generative AI, GPT versus Claude. This is a fair conversation I'm willing to have. But when I'm consulting, I'm often, when I'm working with clients ranging from federal government to, large 500,000 person companies, I have to say, to be clear, the end of the story is not OpenAI or Anthropic or Cohere. We have to look at auto-encoding models. We have to look at distillation. We have to look at speculative decoding. All of these things that you're not seeing on the PR releases of new models, they're what's going to make your task actually sing in production. So a lot of the purpose of that book was to convey that feeling of there is way more here than just how do I prompt GPT-4 or fine-tune GPT-4 to be the best. That's 2 chapters out of 12 in the second edition. The rest of the book is, here's everything else in the realm of NLP, machine learning in general, just what it would take to get your specific task up and running.
So kind of like you start out with the lay of the land, and then you get into some individual things. So it makes sense for a quick start book. And I really want to talk to the person who went to a quick start book and in some way expected that that would lead to progress in AI, and that was their critique. But
I
anyway,
think it was fair. I think we're just kind of warning people like, hey, this guy is not going to go into the math of it, which I do
all
in my
right.
other videos. I have videos going into the math of it, but I said, let's leave that out of this book because we're going to lose a lot of who I want the audience of this book to be. They don't, in a lot of ways, they don't quite care. And I'll send them a link to where they can learn more about it. They want to see the results. They want to see, what does this look like when it works and what does it look like when it fails?
Yeah, that's fair. And I also think that this is useful because here is a problem that I've had with this whole field of AI. For a long period of time, I kind of was sitting in the sidelines and I wasn't really following all the developments that happened in the field of AI. My excuse at the time was, well, I'm a Java guy, and a lot of these things seem to be Python related. I didn't know Python at the time, and any code example, any article that I would read was like, it's all in Python. And, they would kind of mention that at the beginning, like some basic knowledge of Python is required. I know people say Python is a super easy language, and I'm kind of getting to grips with it right now. But for the long period of time, I was like, okay, let them do their thing. I'm just going to wait and see once it becomes more accessible to me. And I was kind of like, there was a lot of buzz, and I was just sitting in the sidelines, trying to catching a little bit of news here and there, but not focusing too much. I know that a lot of people kind of share the same story, right? They have been doing this for a while, and now there is this explosion in AI, and everybody's talking about it, and they come into the field now, and they see a billion things because they've been in the sidelines for so long, right? What you said in the book, and I really do plan to, as a chapter 1, I kind of started reading it last night. I'm still at chapter 1, so I'm going to be
It's
geared
one of the
up and
longer
ready.
ones, to be fair.
Yeah, I'm going to be ready for chapter 2. It seems intimidating just the way you described it, but yeah, I'll tackle it. But yeah, this is a real problem for a lot of developers, right? So they've been watching the sidelines, unlike somebody who's been in the industry like you have for 10 years. So they have to deal with this explosion of ideas, especially considering that this is a field which is moving rapidly already, right? The explosion of ideas that they have to deal with today is different from the ideas that they would have to deal with a month from now, because things have already changed so much. So what is your advice for somebody in this position who's kind of getting into this field now?
Mm-hmm. Read my book. No, you're so, I've been in the field for 10 years. And even today, I still feel, oh, a new model. Oh, okay. Oh, a new way of calculating attention. Oh, okay. And then I'm sitting there reading, thinking, I can read all these papers. I mean, I was a grad student for a while. I could do that. But at a certain point, I need to be able to map all of this to how much do I really care about this in the moment? And again, that comes back to the format of my book, which is, it's easy to say this book is a gentle guide to LLMs or transformers or NLP or whatever. And I've written books like that, very specifically gentle guides to machine learning and feature engineering, which is, nothing, we're going to go from 0 to 60 in 300 pages. But exactly to your point, I know, again, as a teacher and someone out there in the field, I know that mentality that a lot of people have, which is, whoa, what happened? We went from 0 to 100 in what feels like 3 months, and now we're at 200, and we're not stopping. What's going on? And again, I tried to translate that feeling into the book to say, there is no such thing as a gentle guide. The gentle guide to LLMs is the last 10 years of research. We're not doing that here. This is the crash course, jump in the deep end of what's going on and to put another way, what's more evergreen than hype. And that's something I also, maybe not struggle with, but think about extremely hard, and I try to be really thoughtful about that idea. Put it this way, I'm currently editing my second edition. That's what I was doing before I got on this call with you. And part of that editing was taking a chapter that I had originally written for GPT-4, or sorry, 3.5, which was the only model that existed at the time of making the code, and saying, I hope I can just swap in GPT-4o and everything still basically works. And it did. I just ran through the code, no errors, all the tests passed, and said, great, everything still works exactly the same as I intended to. Because a lot of what I'm trying to get across is things are going to change. And one of my, not least favorite questions, but one of the questions I struggle with genuinely is, hey, is this model that just came out today better than everything else? And I have to, again, look at that and say, I can't answer that question, because there is no answer to the question of, is model A better than model B? That's not a fair question, right? Because if you're simply evaluating models, not the UIs on top of them, not the voices on top of them, I don't strip that away. Even just evaluating the models underneath, how factually, accurate are they, or how funny are they, or whatever that is, you still can't really do that without a test set. And that test set is going to describe a set of tasks. You may not know it. It may not be labeled that way, but if you have 100 conversation examples or a benchmark like MMLU or Truthful QA, those are testing for specific things. So you could say, sure, GPT-4 is better at task A than model B or something like that. It doesn't really answer the question of, well, okay, which one should I use in real life? Because there's pricing considerations, there's open versus closed source, data security considerations. There's a whole host of things to consider outside of that. So it's then again, a gentle guide to that would be several decades of knowledge in machine learning and AI, which you can't really get across in a single book.
So you're saying there's no easy way around it. You just have to kind of dive
I don't
in.
think there is. I genuinely don't believe there is here's the thing, a single pathway to learning a lot of these topics. Because at a certain point, and this is true of any learning journey, there is no single way to learn calculus. I have come to learn. There is a expected way to teach calculus through Calc 1, 2, and 3, as most people know them. But that linear path through calculus even doesn't work for everybody. It's actually a lot of the reasons a lot of people hate math is because when you take a lot of people and you give them all the same learning path, it's only going to work for some of them. Some people don't, frankly, need to know about integrals. That's okay. I'll rather stay in the differentials, stay in the derivatives, and how rates of things changing over time, because that might be more relevant to what you're doing. I'll remind you that integrals exist, and if should you need to learn more about them, here is a resource. But for you, I don't think you're going to need it right now. That's not possible in a lot of learning environments. And again, with LLMs, it's, well, I'm going to lose you at some point if I go from A to Z. So I should at least rather give you letters of the alphabet along the way and say, listen, if you need a recommendation engine, turn to page 200. If you need fine-tuning techniques, turn to page 250. Everything before that is not really going to be of much help to you.
Yeah, I guess that's probably what would come close to the easy way. It's basically just kind of prioritizing what you want to learn and just focusing on that. That would work if they don't stand on top of like this huge platform of foundations that you need to know to even get there. So let me ask you this differently though. Consider the typical demographic of my audience, who is like, they've been in the industry for a while. They're good at coding. They have built backend applications in Java. Now they want to kind of catch up with the advances in AI and trying to see how they can kind of take that and apply it to their job, right? They're not going there and training models, right? They're basically looking at just the inference part of it. How can you apply AI to their job? What do you think is a good place for them to start? Apart from reading your book, of course.
Good question. And apart from reading my book, I don't get I give the same advice I would give 10 years ago, which is pick a project that you care about or for work or whatever it is, and start applying different models to that task. And it's going to come with a lot of trial and error, right? I mean, step 0 is read something like my book or someone else's reference article on here's how to prompt engineer, here's what is happening under the hood, and here's how the parameters, the inference parameters affect that. That's, again, the chapter 1s of the world. But once you get through that, it's time to apply, because what's true more than anything is that the interaction between humans and computers have never been closer. 10 years ago, to talk to a generative AI, and they existed, to be quite clear, generative AIs existed 10 years ago, but to talk to one, you had to fine-tune it yourself. There were no really pre-trained generative AIs. That did not exist. That concept did not exist. If you wanted one, you had to make one. And that's what my company did, to be clear, like at scale. For enterprise customers, we would build generative AIs off of their own conversational history, again, 10 years ago, because the process was expensive, not that good compared to today's architecture, but it worked at sufficiently large data sets and sufficiently small utterances coming out. It made sense. It made conversational sense. Mm-hmm. But that was only possible by trial and error, quite frankly. We had to test out our system with 100 examples, 1,000 examples, 10,000 examples, and report the differences between them. So today, this is all to say that today, if someone's trying to get into this field, quite frankly, the way that most people are finding success is through a very kinesthetic process, which is, well, I can literally pay OpenAI $5 to ask GPT-4 at the API level to solve this task, play around with different prompts, turn the temperature up and down, see what happens, and say, I'm starting to understand what makes this AI tick or what makes this AI work. That kinesthetic process, up till a couple of years ago with ChatGPT effectively, really wasn't possible before the advent of the playground for AIs. So frankly, the advice is start talking to the AI, and you're going to mess up 99% of the times. It's going to look stupid 99% of the times, the output that comes out, but you're going to learn what makes the output good. And for more references, sure, there's prompting techniques, prompt engineering 101. Those all exist, but it's never going to compare to saying, well, I literally tried prompt technique A versus B, and B seems to work almost every time, and A is just much harder to get it to work. So I guess prompt technique B is better for me.
It's funny how all this advice, first of all, I'm not surprised at your answer, and it seems obvious. But it's funny how all these advices align. I keep getting questions about, this framework and this other technologies. Like, how do I get started? What do I do? Guess what the answer always is? Build an application, build something, just try it. Yeah. It's funny how it all, it's always the same thing.
And frameworks especially are challenging, because I try hard not to, profess a framework to say, like, here are the 10 steps to building an AI application. Because, those exist, and those are often all very good, but they often kind of boil down to, okay, well, what are you trying to solve? Do you have data for it? Can you build a test set? Can you experiment? Can you deploy? Can you iterate? That's been the advice for most software engineers for a long time, which is, I need to build a function for a Fibonacci sequence. Okay, do you have the data for it? Not required. Can you build a test set for it? Totally. Can you experiment different ways of doing it? Absolutely. Are you going to test them against your test set? 100%. Is it going to work at deployment? Yes. Can you iterate on it? Maybe. Who's to say? But that concept is still in my head. This is not a new framework. It's just, and a lot of the frameworks these days are more micro-focused on AI versions of that, which is prototyping versus experimenting, or inference versus deployment, but it's all really the same concepts under the hood.
There's one challenge that I've seen with playing around with AI, though, and I want to pick your brain on it. So suppose I'm working on a framework, like let's just make that comparison, right? I'm working on a Java framework, and I'm learning by doing, right? I want to learn how to do this. I pick an app that I use that framework to build. I realize something goes wrong. I look at the logs, figure out, okay, this is exactly what went wrong. I learn how to fix it. and then I iterate. So there is clear instant feedback and a clear indication of what the right path is, right? Which is, I think, essential for learning. There are like three factors which help you learn, right? So you need to put in a lot of iterations, you need immediate feedback, and you need to have a sense of progress. Here's a problem that I've had with AI, playing around with AI. I get immediate feedback, but when something doesn't go quite right, I don't know which way to go. And most of the time, it's basically trial and error.
Mm-hmm.
Has this been a typical experience for people learning? And if so, how do you go about it? How do you know? Like when something goes wrong, how do you know what to do next when the next step isn't so clear?
A lot of that comes back to our earlier discussion of determinism, which is feedback is great when it's deterministic, right? Feedback is less useful when you are trial and erroring something and you say, this prompt seems to work 8 times out of 10, which is, what does that mean? Does that mean the prompt is broken? Is the AI? Is it the inference parameters? This, again, comes back to this idea of there's a very flat world of things that could be going wrong, and it's your job to figure out how to pull these levers, right? If you, any of deep learning engineers out there, you'll know, the famous question of how do I know what hyperparameters to set while training my model? They go, well, there is research to figure out optimal parameters, but most people just kind of have a gut sense of what it should be and they kind of tweak it from there. And that's fine. That's okay. And a lot of that passes through here, which is I have a good sense for what kinds of techniques are going to be good, but I will never say this is the right way to do it until I have a test set to test it against. For example, a very common question that I get asked is, hey, I'm using AI to write my LinkedIn posts for me, or help me write my LinkedIn post for me, which I do, by the way, just hand raised, to say, and they say, well, but everything it writes is so stilted. It all sounds the same. Mm-hmm. And I go, well, chapter 3 of my book, there is a prompting technique called few-shot learning, or K-shot learning, which basically says, well, I'm going to give the AI examples of what I like to see before asking it, write me a LinkedIn post about X. So I'll take 10 examples of my own LinkedIn posts, or frankly, other people's LinkedIn posts that I like or are doing well through the algorithm, and say, can you first describe to me why these posts might be doing well? That would be called a chain of thought, basically asking it to explain its reasoning. And then say, okay, now write me a LinkedIn post about blank. So you've combined two prompting techniques there, few-shot learning and chain of thought. But really, at the end of the day, it's also saying, well, how would you have done this with a person? Which is, you ask someone to write a LinkedIn post for you, and they write one, and you say, I don't like that. And they go, well, you gave me no further instructions. You just said, write a LinkedIn post. I don't know what you like. I don't know what kind of style you want me to have. And this isn't to say that AIs are exactly like people. They're absolutely not. But that teaching technique, which is, I want you to solve this task, but before you solve it, I'm going to give you examples of LinkedIn posts, preferably with reasons on why I like them. Mm-hmm. And then I'm going to ask you, AI/intern/me, I'll ask myself, do it now. Now you do it. Knowing what I like and why I like things, now write me a post. And that iteration, that feedback can become there can be much bigger delta there. So when it comes back to that framework of, you have to show progress, you have to have feedback, instant feedback. You have the instant feedback, you're right. And as far as how do I know what's wrong, a lot of it comes down to, well, what does the AI actually know? And does what it knows conflict with what I want? It knows what a LinkedIn post is, but it doesn't know what I want in a LinkedIn post. There's a disconnect. So that's why a lot of people say the AI feels stilted. Well, of course it is. It's the same AI for everybody. Right. It's effectively writing in a similar style for everybody. You have to tell it what you want. And a lot of 9 times out of 10, the problem stems with there are ways of telling the AI what you want quickly so that it produces something that actually aligns with your expectations, whether it's chain of thought, few-shot learning, what have you.
And it becomes a better representation of what you want to convey. And it feels less like cheating, right? It becomes more of a tool then rather than just handing off the work to somebody else. Yeah, that's true.
100%.
Okay, so this applies for creative stuff or generative stuff. What if you have an AI that's trying to solve a problem that needs to have a specific output, right? So this is a subjective thing.
Classification.
You can say classification is one thing. Using tools is another, right? So I ask OpenAI to run this function in a certain way or run these 5 functions based on certain things that it figures out. I think it eventually comes down to a classification problem, but you get the idea, right? So it's like, how do you do one-shot learning or few-shot learning for things like running tools or, planning out actions to do which are more objective?
The idea of, so what you're describing is effectively an AI agent, right? That idea of a generative model with access to tools. And it's funny because this is one of the new chapters in my second edition, because it is, for me and for any implementation out there, it is effectively it is a set of prompting techniques, which is, well, each tool must be defined, and each tool should also have a description of when to use it, what the input is, and what the output is most likely going to be. For example, if you want to write Python code or Java code, you might have access to some way to run code and actually execute code and see the result of that code. And you say, well, choose this tool, this Python environment or Java environment, pick this tool if what the person wants is code. How do you know if what the person wants is code? You could use a chain of thought prompt, which is basically forcing the AI to explain itself before actually taking a task. So your prompt might say, here's an example conversation. I'm going to ask you something. You're going to provide me a thought process. And at the end of that thought process, you're going to pick a tool from this toolbox, which I have defined at the top of the prompt. Google search something, write Java code, check my stock balance using this API. And then from there, a pattern emerges from, well, as long as I can define the input output and I can describe to the AI when to use this, I should be able to add as many tools as I can and chain them together to solve a task. So if I ask it, what is 1 plus my stock portfolio? You would say, okay, AI, go. It'll say, okay, thought. First, I need their stock portfolio balance. Action, check stock balance. Run API call through the tool. Observation, here's the result of the API. Response, their stock balance is this. Next thought, run Python environment. Do 1 plus, that number. Execute. Observe. Result is this. Hey, it looks like the answer is $1. Sorry to hear that, or whatever it is. But that idea of chaining together through chain of thought and few-shot prompting, that's usually what agents are at the end of the day.
So it would be kind of playing around with the prompts either way, no matter if it's like a creative output or if it's more like running tools. You basically, it's also prompt engineering at that point, right?
It's most generative AI tasks come down to prompt engineering. Some of it is fine tuning. There is research now even that says for a majority of tasks that people want to do day to day, the prompt engineering is as good as fine tuning. As these models get bigger and bigger and better. And also, I'll add one more thing to that, just to be explicit. It's not just about a gut check or I'll try it over and over again. Before I do this, I'll write out test conversations to say, when I ask you this, I expect this line of tools to be used. So you are able to quantify, are you actually following the thought pattern I expected you to follow? All of that is still possible and still frankly required in my book, pun intended. That is required because it is one thing to say, hey, this looks good, this feels good. But if you don't have proper testing in place, you also don't have proper iteration techniques in place. If you don't have a test set of 10, you can't grow from 10 to 20 and 20 to 100. If you have no test set, going from 0 to something to test is hard. Going from 10 things to test to 100 things to test is still hard, but it's no longer a a development challenge. Now it's more of a data labeling problem or data generation problem.
How do you go about creating the test set? Is it basically what you said, like you have a certain input and a certain output, and as you tweak the prompts, you basically run it through those set of inputs and outputs and make sure it still works?
That's the basic idea. Yes. I mean, for most tasks, that's going to be possible. Now, especially for things like ease classification, yeah, it said A, I expected A, good. It said C, I expected F, bad, easy. But when it comes to more generative tasks, the pattern still holds for the most part by saying, okay, here is the task that I gave you, and then here is the list of tools I expected you to say. But coming back to math, there's more than one way to prove something. You didn't have to follow that tool set. So you're really testing it on two things, which is what was your chain of thought to get there, and was your final output the name or the number or the phrase that I was expecting? And if it's a number, it's easy to check, right? And if it's a phrase, it's harder to check, but you can still use something like semantic similarity to say, yeah, you gave me my stock balance. You gave me a number and said your stock balance plus 1 is blank. You generally provided an answer like that. Is it the right number though? We can also test for it. So it comes down to this idea that there is no longer one input, one output in a lot of cases, because that one input could yield multiple different artifacts along the way. Did you think about the task correctly? Even if you got the answer wrong or right, did you at least think about it in the way I was expecting? Did you think about it in a way I wasn't expecting, but still got the right answer? I have to interrogate that now and say, well, maybe I'll add this as a correct example to my data set. And that iterative nature, especially because these models are non-deterministic, helps you expand that testing set. So whether you're writing them manually or using synthetic data generation, like saying, hey, GPT-4, here's an example test set. Can you write me 3 more? And then I'll look over to them and see if they actually make sense. That's also valid as long as each example there has to be some human in the loop at some point saying, I agree, this is a good testing example. And it's a lot easier to look at a synthetic example and say good or bad than it is to write one from scratch. So I'm not opposed to synthetic data generation, but there has to be someone who's close to the task saying, this is actually a good example that is representative of a type of question that is not well represented already in the data set. It would be a good addition to the set.
Okay. So there is a human in the loop in terms of preparing the data set, but then once the data set is prepared, the testing itself is going to be automated as you tweak the prompts and everything else that goes along, no matter what the journey is. So for example, if you use chain of thought thinking, your testing is going to eventually look at just the output and you're not manually looking at, okay, was the chain of thought right?
You could.
Right?
You could. I mean, I don't see why not. If I am testing for the chain of thought, put it this way, what I recommend a lot of people use chain of thought for, not just to get the answer more performant, which is, by the way, the main point of chain of thought is to get better answers out of your model, but it also could be a tooltip. If you're actually providing this answer to someone and saying, why did you say this? Well, show them the chain of thought. This is what the AI said, and give your users a way to give not just the answer a thumbs up, thumbs down, but the reasoning a thumbs up, thumbs down. Because if you're getting a lot of people saying, this is not how you should be thinking about this, and you're kind of crowdsourcing that feedback, it's going to yield a lot of ideas about how to tweak the prompt to say, okay, clearly it's not even thinking about the problem the right way, let alone getting the answer right. So we have to give it some examples, few shot examples with reasoning that is more in line with what we want. And then hopefully that feedback gets better over time. So it's whatever is going to make the most impact to your users.
I remember someone saying it's almost like you're working with the AI is like, you have a new intern, or sometimes working with a 8-year-old or 9-year-old, you have to teach things that you wouldn't normally teach like a fellow employee. But then your hope is that at some point they're going to get to a place where you can kind of treat them as a fellow employee and, a colleague. Okay, here's another thing. Like when we talk about prompts and all, I want to see how you think about this. It's fascinating that in some of our conversations, we treat the AI like a human, right? We anthropomorphize and we say, okay, the AI is thinking. Considering your math background, do you sometimes go, okay, why is it this way, and what's happening? So there are a lot of prompt techniques, even the chain of reasoning. There is this agent-based model way of prompting where you say, imagine you are this person, like imagine you're a Java expert, or imagine you are a proofreader, kind of giving them personas. Do you ever go like, why does it work, right? What is happening in the math behind it that makes these certain prompt techniques work?
Yeah, I don't wonder, because I'm pretty sure pretty sure we know the answer.
You know
as
the
a
answer, all right.
community. I mean, pretty sure. Again, there's a lot of debate about this, and the most common consensus is it's reflecting the training set. The reason it responds well to things like recall or imagine this is that it's what it sees a lot in the wild. That's how people speak. When they want to teach you something, they say, imagine you're doing this. It's 2024. This is how we should be doing stuff. It's just seen that a lot. So when you prompt it like that, you're basically forcing it to say, ooh, I've seen this before. I know what comes next is information about XYZ. So I'm going to get myself ready, because remember, it's thinking one token at a time. So if you start that way and it remembers seeing words like that in the past, it's much more likely it's going to recall that information. Now, that's more of a qualitative response. A more quantitative response would be, again, another new addition, because of questions like this I get all the time, is that you can actually probe for information out of an LLM. This is actually the most recent newsletter post that I wrote. Actually, the second most recent newsletter post that I wrote was about probing LLMs, which is basically a fancy way of saying, when you insert text into an LLM, there are multiple representations, embeddings, vectors that represent the tokens along the way. The final representation is what's used for the next token classification. But if there's 24 layers of that LLM, of the decoder, encoder, or whatever it is, every single one of those layers has an embedding associated with those tokens. So what you could do is say, well, before it even speaks, I'm going to grab the embedding from the middle of the model and say, I wonder if I can regress or classify or perform some tangential machine learning task on top of that to probe or extract data information from that model. Example, one of the example that I did, or one of them, was to basically input a benchmark of math. It's called GSM 8K. For those of you who don't know, that is a collection of grade school math word problems. Tammy has 10 eggs at an Easter egg hunt, and she gives away 3. How many are left? Harder than that, but things of that nature. Okay. And the idea would be, well, okay, fine. If I just say that into an LLM and let it speak, it may get the right answer. If you do a chain of thought, it's more likely to get the right answer. But where is this coming from? Does it actually do any calculations on the back end? And what you find is, if you input the text and you don't let it speak, and you grab the embedding from the middle of the model, you actually can build a linear regression on top of those embeddings to the right answer of that question. So then the question becomes, okay, is that because it's seen this word problem before, and which you can check in the training data relatively easily if you can find that word problem somewhere? Or if it's not in the training data, you could say, well, clearly it's doing some calculations on the back end, on the, quote unquote, on the back end within its parameters. Now, this is where it gets more philosophical. Is it a calculator doing math, or is it simply reasoning together different word problems it's seen? That part is still up for debate. We don't know the answer to that. But it has been shown that this information can be unlocked through prompting. One of the other examples I did was, you give it the name of a person who has been born or died, and you say, when was this person born? Like Albert Einstein. If you just say the word Albert Einstein and you do the probing and you regress the token embedding to his birth year, it can do it with a relative degree of accuracy. If you change the prompt to say, when was Albert Einstein born, or what was the birth year of Albert Einstein, it's a better classifier or regressor to the year. You're unlocking the information through prompting. So prompting can actually unlock that information, even if it was already there, hidden in the weeds. It's quite fascinating.
But isn't that what the LLM would do anyway? So you going in, getting the embedding, and then tracing your way through is what is exactly the same as what the prompt would have triggered, right? Or is there a difference there apart from you doing it versus the inference doing it?
It's more so the Albert Einstein one is kind of the easy example because I'm basically asking it to recall a fact that you've probably seen 1,000 times in your training data. But the math one is where it gets more interesting because if you've never technically seen this word problem before, you're either actually doing it in your parameters, you're actually solving the task in your parameters, A, or B, you're taking together multiple different word problems and putting them together and getting the answer that way, less likely, or C, you have to talk yourself into the answer by saying, okay, let's break this down. Step 1, what is an egg? Step 2, what does 10 mean? And it has to go through all of those steps to finally get the right answer. That's different than just knowing the answer up front, right? If you ever stall for time, you're kind of talking to like, well, I guess if you do it this way, when Google asks you how many windows are in the world, you're like, I guess there's this many buildings and this many cars and each one has 4 windows and 10 windows or whatever. That's chain of thought. You're talking yourself into the answer versus saying how many windows are in the world. You have 3 seconds to answer the question. Those are different problems. How quickly can I do that?
Yeah, that's fair. This is probably a philosophical question, but do you ever wonder if this is how our human brain works? Do we do chain of thought thinking, but it's so kind of embedded into us that it's burnt into our neural pathways and we don't think that we're doing it? Do you feel like we are kind of like, as we build these systems and as we kind of try to find ways to make it more intelligent, we're kind of replicating what the human brain does?
I have no idea. I'm so sorry. I get this question so often, even 10 years ago when it was like RNNs, LSTMs. Do you think this is how the human brain works? I always have to say, I don't know. I'm a mathematician. I have no idea how the brain works. I've read all the blog posts saying this is how neurons work in the brain. And I'm like, I remember that from chemistry or biology and also a little bit of chemistry, but I don't know. So to your point, I wish I knew the answer. Does it feel like that's what we do? Sure. It feels like what I do a lot of the times, but is that just because I'm projecting that onto my own thought patterns? I have no idea. I wish I knew, frankly. If anything, if I were ever to take a sabbatical, whatever that would look like in my startup life, one of the things I would want to do is finally get to the answer of, have neuroscientists, are neurologists, neuroscientists, are they aware of these comparisons that people make to neuroscience? And what do they have to say about this?
I feel like this is a challenging problem because if you ask this to like a neurobiologist or a neuroscientist, they're gonna go, I have no idea what a language model does, right? They have the opposite problem. I think this is a trap because I read somewhere that we as humans often have this propensity to equate the most technically advanced concept of the age to the human brain. Mm-hmm. Because I remember there was this thing about when the Industrial Revolution happened, right? And there were all these fancy machines. They were like, these machines work like the human brain because that was the peak of technology at the time. So I feel like, we often tend to do this because we attribute it to the peak of technology in the biological side with the peak of technology that we have created. But having said that, I believe that, I don't know, I have no idea myself, but just a gut feeling. I feel like we might tend towards how the human brain works because what we are trying to do is to simulate it in some way. And I feel like the progress we make we are going to, again, there's a bit of evolution that's happening in the AI sense as well. We're going to try out 10 ideas and one of them is going to win. I feel like that evolution is kind of going to mirror the biological evolution in a way. But it's just a gut feeling that I have. Maybe I'm completely wrong. But this is a problem. We have two different sciences which are so advanced, we have no idea what the other person knows.
In a lot of ways, a lot of people don't care, right? To them, it's like, well, it's doing what my brain would have done. So do I care if it's doing it the same way? Maybe. But for I would argue for a lot of people out there who are just trying to implement this, they say, well, look, I'm going to prompt it well. And yes, I understand that if I prompt a human well, they also get smarter. So I see the similarities. But it's at the end of the day, are my tests passing? That's what a lot of people are really just want to care, what they care about.
How much do you think they should care about in terms of, I feel like there is some amount of knowing how it works that that affects prompting techniques. For example, what we talked about just now, chain of reasoning. Well, knowing that this helps affects how well you can work with AI and how you write your prompts. If we know that it's human-like, we can kind of translate the years of learning of us interacting with other humans to better prompting techniques. But even otherwise, let's take a step back. And I'm going to ask you, how much of the underlying technology does somebody need to know for just writing prompts and working with ChatGPT and the inference side of things?
Yeah, there is a baseline knowledge that I think is required to do any level of prompting. One of those things is the architecture of the model. It basically boils down to two: autoregressive versus autoencoding. Autoregressives are generative. When we say generative AI, these are autoregressive models. They speak one token at a time.
Yeah.
Versus autoencoding models like BERT, XLNet, Roberta, which is a variant of BERT. They don't know how to speak. They're not trained to speak. They're trained to read quickly and at scale. So depending on what your task is, picking the right architecture, knowing the two architectures, frankly, is the first fork in the road. Now, assuming you're going down the generative road, most people do. But again, a lot of my book is saying, don't forget this pathway. For some tasks, it's what you need. If you're going down generative, the prompting, so what I just said, which is, well, the probing indicates that by prompting, I'm unlocking information along the way. It's getting better at producing the result, not just at the end through a benchmark, but literally the model's knowledge seems to be getting unlocked through prompting. Yeah, that's going to give me a hint, not just into the prompting techniques, but what the model knows. So that same example, I did the same probe across, it was Llama 3, Llama 2, and Mistral 0.2. And for a grade school math, Mistral across the board at the same parameter size was much better than Llama. Now, only when Llama was at the 13 billion versus, Mistral's, I think it was 7, the one I was doing. Yeah. Only then did it actually beat Mistral. But parameter for parameter, 7 billion versus 7 billion, Mistral was just much better at probing for the GSM answers. So that indicates to me, not just a prompting technique, but it also indicates that maybe this model has more unlockable information about math than Llama. So that's now also going to affect my model choice. You can't probe GPT models. You and I can't, OpenAI can. But that kind of probing technique also speaks to, well, which model is responding well to which prompt technique. Now, again, the rebuttal to that is don't do that, just test the benchmarks. But again, benchmarks are also testing things like, how's their chain of reasoning? How good are they at few shot prompt? That's all getting to the right answer at the end of the day. I'm trying to test what's the information that I can potentially unlock from this model, whether through prompting or fine tuning, which is a better baseline to even start with. Those kinds of questions can now start to be answered through these kinds of techniques.
That's pretty cool. You mentioned a couple of open source models, what has worked best for like I don't want to ask you what's the
Are
best
you
model
asking the
because
question of which
no,
model is
no,
best?
no, 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 no. I thought that it could be interpreted that way, and I immediately stopped. This interview is going so well so far.
I'm having a great time.
And I asked you what's the best model. I ruined it all. No,
No,
my
it's perfect.
question
Leave
is.
that in. Editor, leave it in.
Oh, I'm definitely gonna leave it in. No, my question is, we've seen these new models coming up which seem to excel in all of these benchmarks. What has been some really good announcements that has excited you? Mistral has personally been very exciting for me, and even Mixtral with the mixture of experts thing. What has been your favorites that you've played with and gone, wow, this is awesome?
That's good. It's a good question because it does speak to that idea that there's always by the time you publish this, there's going to be a new model, right? There's going to be
Sure.
something else people are talking about, right? But it all comes down to those first principles of, well, better for what? Is it for Q&A, for math, for classification? So to answer your question, what I currently get very excited about is the kind of the ratio between performance and model size. And I think in 2024, we're seeing a pretty big shift towards, well, what if models weren't a trillion parameters because those are only available at the commercial level with companies with billions of dollars or hundreds of millions of dollars at least. But how do you get Llama 3 to be, call it even 20% worse than GPT-4, but at only 8 billion parameters? I'm making the 20% up, but is that possible? And is that going to be possible through training data? Is that going to be possible through an architecture change? What does it take to increase the ratio of performance to parameters? That for me is one of the more exciting. When I see something that says, always take benchmarks, by the way, with a grain of salt. 8 billion parameter model is beating a 70 billion parameter model at this benchmark, both trained on similar types of data. That to me is interesting because there's something fundamentally architecturally different in the way they've done training, inference, something in that smaller model. Because the easy answer is to say, well, bigger is better, more data is better, right? That's easy to say. And it's not always true, quite frankly. Now, OpenAI has proved it still is true at gigantic sizes of training data and gigantic sizes of models, but that was kind of, in a way, expected, right? Models that I was building 10 years ago, from a parameter count, were in the less than 1 million. So now when someone tells me this trillion parameter model is smarter, I go, yeah, of course it is. I just didn't have $100 million to do that 10 years ago. This architecture, the transformer, didn't exist. I just couldn't do that. But of course it makes sense that the bigger the model is, the more data you use, it's going to get smarter. But the hard part now is, how do you distill, pun intended, because that is a technique for creating smaller models, how do you distill that into a smaller model that can fit on my phone, that can fit in my browser? That's the exciting part. And outside of that, I love to see new benchmarks coming up. Benchmarks, like I said, with a grain of salt, there's only about a dozen or fewer benchmarks out there that people kind of quote unquote care about. And most of them were made by the same institutions, the Allen Institute, OpenAI, some collaboration between Stanford, Princeton, Berkeley, name it. There aren't that many institutions creating benchmarks. They're also creating the models too. So that can get a little murky. But every so often we get a benchmark saying this is a benchmark for software engineering, which is a real one. I believe that was put out by Princeton. I think it was Princeton. I'll have to double check that. Put a little text here saying Sinan was wrong or right. And the idea was that a company took that benchmark and said, we built the world's first software engineer. And they used that benchmark as proof. They said, we set GPT-4 and I think Claude on this benchmark versus our LLM, and our LLM beats those two gigantic models at this benchmark. Now, assuming we trust the benchmark, that's powerful. So I'm always on the lookout for, well, what's the task people care about? And what benchmarks are we using to prove that the AIs are doing that task? And then finally, well, how big is this model? How big did it have to be to beat GPT-4 at it? Those are usually the three things that get me the most excited.
No, that makes sense because I have tried a couple of models which scored really well on the benchmarks, and I get benchmarks are controversial. There was this controversy about the tests being leaked into the model, so the model was trained on what it gets evaluated on, which is
and if they don't share it, how are you going to know?
Yeah. So there was this model that came up, 120 billion parameter model. I think it was called the Goliath or something. I think a few months back. I was super excited about it. I spent a lot of time figuring out how to run it. And, I rented a GPU pod on the cloud. I ran it and I was super disappointed. It's like, this isn't all that it's hyped up to be. So on the one hand, yes, the benchmarks are, you got to take it with a grain of salt. And then on the other hand, what you said makes sense, that it is all use case based. I'm sure there are a bunch of use cases where Goliath is the best tool for the job, but for what I was doing, I got better results with Mistral, which runs on any computer right now, I would imagine, versus something like Goliath, where I had to rent a GPU pod for. Do you feel like there is some point where we are going to get diminishing returns, though? Because, Llama 3 was super hyped up, and it was like, I was super excited to try it. And when I did try it, it was like, it isn't all that different from Llama. Yeah, a little bit better, but I don't know. I was like, I waited a year for this thing, and it's like just another model. Do you think that there is some kind of diminishing returns with the training techniques that we have today, the parameter size, and we have to just come up with like innovative ways of doing this, and size isn't going to be so much of a differentiator anymore?
Yeah, I mean, short answer is yes. I mean, one of the big reasons that GPT-5 is so hyped is the rumors of the novel training technique. It's not novel training data. I'm sure there is, but there's rumors of a novel training technique. The way they actually train the model to again, rumored, correct it, almost basically self-correct itself every step of the way while thinking, instead of basically saying, no, that wasn't the right token, is actually this token. Reinforcement learning versus fine-tuning, techniques are going to end up showing the bigger deltas at the end of the day. To answer your question, yes, there are going to be, everything in the world has diminishing returns. Well, that's not true. Anything technologically speaking, software related, will have some diminishing returns, assuming you keep techniques relatively steady. Only through breakthroughs in training and inference techniques will we start to see deltas in certain parameter or in certain metrics like latency, throughput, or just performance and this alignment feeling of that model. And that's why I often will say, at the end of the day, a lot of the times it won't matter which model you're picking, especially if you're fine-tuning the model to your own custom data set, because, well, whatever model you pick is going to end up learning, for the most part, what your data is. So do you want to train a 100 billion parameter model, or are you going to be able to train an 8 billion parameter model with the same data set and get similar results? Case in point, I do, of course, a case study where I fine-tune GPT 3.5 and I fine-tune Distillbert to do a classification task. And yes, I know it's classification, but it's still an NLP task. Distillbert is 5% better on the testing set, and it took less than $1 to train it versus $80 to train it on the OpenAI's API. It's a no-brainer. Why would anyone pick the GPT 3.5 in that case for that data set? So like I said, it all comes down to, well, what are you actually trying to do? What is your task? And yeah, those diminishing returns are already showing up. I make a joke that it's Llama 3, but it feels more like iPhone 14. Where it's like, okay, I get it. It's better, but it still has a really good camera. It's still the best camera in the world, whatever that might be. Well, I think Google Pixel, whatever, but yeah, it is, because the big delta from no Llama to Llama, or no GPT to GPT, was like no iPhone to iPhone.
Yeah.
But iPhone made huge advances every single iteration for a while because the hardware was still struggling to keep up. And now we're in a relatively similar state where the hardware technically exists to make these deltas. It's just inaccessible. No one can afford that if you don't have hundreds of millions or tens or hundreds of millions of dollars. So it becomes an accessibility issue, which is I would love to make Llama 4 myself or with whatever resources. I just personally can't afford the resources that would go into that. So I'm stuck, frankly, using the pre-trained models that Meta or Google creates for me because I just don't have access to those hardware resources.
It's there are a couple of ways to solve this problem. I want to ask you this because this is something that I've been struggling with as well. On the one hand, you have these intense resource requirements, which kind of makes this whole field be more monolithic, monopolistic. The people who have the big bucks can release better models. And on the other hand, you have these things where, first of all, there's cost associated with it. There is security issues, right? I can't send my personal data to OpenAI. There are alignment issues. We talked about alignment. All these different companies have their idea of how the model needs to be aligned, which may not fit everybody. Now we're looking at these small companies who have these challenges, and of course the training being better for certain use cases is like, why do I have to pay a large company for this while I can just take Mistral and train it? So I have these two opposing ideas, right? One is, well, the future is going to be big companies owning the technological advancements. And on the other hand, you have all these challenges that these small companies have with adopting those big company solutions, and their only solution is to use open source and train. Where do you think this is going to go? I know it's like conjecture at this point, but where do you think it's going to go? Do you think the big companies are going to kind of adapt to make this more accessible? Or do you think accessibility is always going to be a problem and the only solution that these companies have is training and fine-tuning?
I think the worst answer in the world, both things are true at the same time, which is, and there's a supply and demand issue, which is there's a demand for AI and the supply of AI is, frankly, relatively small. Obviously new models come out all the time, but when you think about the models that people talk about, there's about a handful. There's fewer than a dozen families of models that people tend to think about when they think of generative AI, right? Mistral, Llama, GPT, I'll put BART in there. There aren't that many.
Yeah.
Interestingly enough.
Before
but to your point,
Mistral, it was just Llama, right? Basically the whole open source community was dependent on Llama. That's what started everything.
Kind of. So GPT-2 was actually open sourced, I believe, in 2020. So the idea of open source, funny enough, the idea of open source LLMs started in a lot of ways with OpenAI. Now that was, to my understanding, the last autoregressive model they've ever open sourced. They've open sourced like Whisper, for example, which is, a different type of model, but they've never released an open source autoregressive model since then. There's actually one of the questions I asked when they were showcasing GPT-3 to some developers, and I asked that question, to which Sam and the team were like, "We will," and I was like, "Okay." And so far, I haven't seen one, but the idea that people want more, they want their own personal AIs, they want data security, that demand will both fuel the innovation that we were just talking about, which is, well, we need fewer parameters to be more performant. How do we do that? It fuels that research by that demand. But at the same time, it also fuels Meta's product research team to say, look, people want open source. And we're already seeing this. Meta would have never open sourced at least the parameter weights of Llama. They did not open source the data. They did not open source any of the code. The only thing they open source, and frankly, behind a gate where you had to sign something saying this is how I will, a license that you have to sign. The only reason they're doing that, in my humble opinion, is their research team saw the writing on the wall, which is people crave doing this themselves. A lot of companies want to do this themselves. A lot of people want to do this themselves. So they said, fine, let's give it to them while also providing a paid version, Meta AI, right? Let's give them a way to use the AI behind an API, behind a UI, but also provide some level of open source to kind of placate the community and say, look, we're being open source. This is what you wanted, right? And more companies, I think, TikTok now has an open source community, which I don't know what they've open sourced, quite frankly. Intuit, I believe, is trying to get more into open source. Corporations now believe that open sourcing is the right way to do PR because they're responding to this demand. So the demand of personalized AI fuels both research to make these models more efficient, open source, and also fuels for-profit corporations to say, well, this is what the people want. We're going to give it to them on some level, which fuels that monopolistic urge in our society.
What you've described is the best case scenario. That would be
fair.
awesome.
That is very true. That was a very optimistic, which is unlike me. If people have ever heard me before, that is often unlike me to be that optimistic. But yes, that's hopefully how I would love to see it.
No, but I think it makes sense that it would work this way because I would have never imagined, if you had asked me 5 years ago, if a company, especially something like Meta, would spend billions of dollars training something and then basically give it out, it's I would have never believed it. But it seems like it would work, and it seems like that's the way forward. So but, in 3 months, when we're all reading some New York Times article saying Meta has announced they're not going to release Llama 4 publicly. Here we are. Now we're just back to the old impulses of that technological system. The haves can make these models, they'll put it behind a paywall and say, now you have to pay us to make it good. So while we are in this wave of open source, people love the hype of new models coming out, being able to be downloaded. Allen Institute has this extremely open policy of saying, we're going to release the models, the code, the data, everything you could need to do this from scratch. While we're in this cycle of hype for open source, it's the time to do the research. This is the time to figure out the research that will force companies like Meta, Google, and OpenAI to say, look, now we know how to do it. So either you keep putting up paywalls or join us or be a part of this community. We're not there yet. We don't know how this is going to end. It seems promising. They are releasing things open source, but that can change in an instant, frankly. Yeah, the open source community really thrived when the only resource needed was people's time, because the community can give that. When it comes to money, which is the problem here, is we rely on the generosity of the people who have money. That's when it can get challenging. There are so many things that I want to talk to you, Sinan, that I didn't even get to. A big part of it was, one of the things I want to talk to you was not about using AI solutions, but how AI affects the life of a developer, the code authoring process, the CI/CD process. There's a whole aspect to it where a typical developer both uses AI to build AI. I think that's a fascinating thing that I would love to talk to you another time if you would be kind enough to join me another time. But it was really, really nice talking to you. Thank you so much for your time and explaining all this thing. You clearly are a teacher. I can tell from the way you describe these things. One more, question about, again, your book. Where can somebody find your book? When is it being released? Can you talk a little bit about that?
Yeah, the first edition of my LLM book is already on Amazon. It was released last October. We are releasing a second edition of that book later this year. The code for which, by the way, both the first edition and eventually the second edition's code will be free forever on the book's GitHub. So if you can put a link to it somewhere, I'll put a link to the GitHub, because the GitHub has the code, also has a link to the Amazon where you can buy the book, of course. But for a lot of people, and I recommend this, look, royalties are nice, but this is, like I said, this is for the teaching. So a lot of people or look at the GitHub and say, this is enough for me. And I go, that's fine. That's all. If that's all you needed, I'm happy to provide it. So check out the GitHub with all the code. If you do want to check out the book, there'll be a link to it on the GitHub.
Awesome. Awesome. Well, thank you so much. Thanks for joining us, and good luck with the book. I hope to speak to you again soon.
Thank you so much. I'll talk to you soon.